Welcome to Module 41 of Mechanics of Materials Part 1. Today's learning outcome is to design an engineering structural member or members to meet a specified factor of safety. And so this is a review from last time. We said that design was creating a new component or structure that will meet specifications or performance criteria. We defined factor of safety as being the strength of material over the computed stress that we have, or the actual stress. And we wanted a factor of safety greater than 1 to avoid failure. And so let's go ahead and do an example. This is a wooden truss bridge, rather old. However, similar newer structures have the same basic concepts. And so we have truss members in this bridge that hold the loads. And so let's say we want to go ahead and design one of those truss members. And the wooden truss member is required to support 100,000 pounds load in tension. We want to design for a factor of safety that's greater than or equal to 2 with respect to yielding of the wood. We're given that the yield stress for the wood being used is 4,000 pounds per square inch. And so what cross-sectional area of beam should we design for? And so let's go ahead and start by writing the factor of safety. Factor of safety is going to be equal to the strength of the material for yielding. And that's going to be divided by the max computed stress. And for the max computed stress, we have over here the max computed stress is going to be equal to sigma equals P over A. P is given as being 100,000 pounds, and we want to design for the area. And so our factor of safety is going to be, again, the strength of the material. For yielding, the strength of material we're given as being 4,000 psi for the wood that we're using. The max computed stress is going to be 100,000 pounds divided by the area in inches squared. And we want that to be greater than or equal to 2 for our design. And so the area then has got to be greater than or equal to 2 times 100,000, or 200,000 divided by 4,000. And this is going to be inches squared because the pounds and the pounds cancel from the numerator and the denominator. And that ends up being 50 inches squared. And so the cross-sectional area then that's required is got to be 50 inches, or 50 inches squared or greater. So A has to be greater than or equal to 50 inches squared. And so if I'm choosing these truss members, 50 inches squared, 7 times 7 would be 49. So to be safe, let's go a little larger than that. Maybe we could use an 8 by 8 8-inch by 8-inch, or 8 by 8 wooden truss member. And so that's a simple example of how to use factor of safety, or building in factor of safety into your design. And I've got a worksheet for you to do. This is our campus recreational center on Georgia Tech's campus. Let's say that we have an I-beam that's made of A36 steel, and it's subjected to 130,000 pound tensile load. It has a cross-sectional area of 8.79 square inches. We're given that the yield stress for the A36 steel that's being used is 36,000 psi. And the design calls for a 2.5 factor of safety with respect to yielding. And so is this design of this I-beam adequate for the load that's being subjected to? And so you can do that worksheet on your own. And I've got the solution in the module materials.